Alrighty, so let's get started. This is like the biggest lesson of this chapter. Ultimately, what we are going to be doing is we are going to be adding vectors in 2D. So if you wanted like a good title for this chapter, or not chapter, but this section, then that's what I would call it, is adding vectors in 2D. So let me go ahead and get a pen. Alright. Okay. So as you can see in the picture here, I have three vectors, and I have vector A in the blue, have vector B in the green, and vector C in the red. Just for this example, I don't have any units on these, so these are just unitless quantities, but you'll notice that I did give angles, and so I can see that the angle here for the blue vector is 65 degrees, the angle for the green vector is 20 degrees, and the angle for vector C is simply to the left, or you could say west, or you could say negative 60. Okay, so that's what we're going to be looking at. What we're going to be doing is we're going to be following through those steps from the previous lesson from yesterday, and that's going to help us in deciding how to actually combine these vectors together. Okay, so that's the ultimate goal for today. All right, so ultimately that's kind of what we're looking at here, and we'll go ahead and get started. You can see this is only 8 slides. What's going to happen is it'll actually be pretty expansive in how we're going to go about this. We're going to go through all the steps possible, and then we'll do a few examples at the end. I'll just make up some examples and we'll see how it goes from there. Alrighty. So first of all, if you remember your steps, you can see at the top here that I have step 1 is to find the x and y components. Okay, so that's kind of what we're going to be looking at here. And as we're finding these x and y components, we're going to say, all right, first of all, I need to basically take vector A, and you can see that it is at an angle, so I can't actually just say it's just in the x or just in the y, but instead it's in both the x and the y. And you can see I'm kind of like shaping a triangle here as I'm looking at this. So that's ultimately where we're going to find these components. Okay. Alright, so here's, I'll kind of fill them in. We'll go color by color. So ultimately, here's the x and y components that we are going to create for this vector. And here are the x and y components that we're going to create for the green vector. And then the red vector doesn't have any components. It is the way it is. And so ultimately, this is why we did some practice with trig last chapter, because what we're going to have to do is we're going to have to find, say for the blue vector, there's an x component right there, and there's a y component right there, and for the green vector, there's an x component right here, and a y component right there. And I could call this a negative y component because it's going to go from here, it's going to go over to the right and then down. And remember that whenever you are doing the components, you're going to go from start to finish, and you're going to add them tip to tail. So I'd go over first, to the right, positive x, and then down in the negative y direction. For the blue vector, I'd be going over to the right first and then up in the y direction. So then it would be a positive x and a positive y. Alright, so that's kind of what we got to do first. To find these x and y components, we're going to use sine and cosine. You'll see them on the next slide, but we're going to go ahead and calculate them here first. Might as well while we're at it. Okay, so what we're going to be looking at is looking at the x and the y components. So take a second here, look at that triangle, and see if you can determine whether you're going to use sine or cosine for the x and sine or cosine for the y. Alright, so what did you guys decide on? Do you think you're going to do sine for the x or sine for the y? Right, exactly. So we're going to actually do sine for the y direction, and the reason for it is because the 65-degree angle would be located right here, and I see that the y component is completely opposite. So we're going to go ahead, and for the x component we would end up using cosine then. So I'm going to set up for the blue, and I'm going to say cosine of theta equals the adjacent over the hypotenuse. And if you, recognize this step, that's all well and good, and you can go ahead and kind of bypass this step of writing out the cosine without putting in any numbers. Alright, so my angle once again is 65. Make sure you're in degree mode on your calculator. The adjacent side would be the x, and the hypotenuse is going to be the 80. So anytime that you're given a vector, whatever that vector magnitude is, that's always going to be the hypotenuse. Okay, so it's always going to be the hypotenuse. All right, so to solve this, this is one of the first examples we did the other day. We're going to multiply both sides by 80, and by doing so, it's going to cancel out the 80 on the right-hand side here, and it's going to leave us with 80 cosine 65. So what you're actually going to notice whenever you're finding these x and y components, it's always going to end up being hypotenuse times the sine or cosine. So this is 80 cosine of 65. So I would type that into my calculator just as is. So 80 cosine of 65. And for my purposes, I'm going to use that store function that I was talking to you guys about in my calculator so that I can keep each and every single one of these stored in the calculator as an exact value. I'll write the rounded value down, so it comes out to about 33.8. And remember, we didn't have units there, so I'm not going to write any units. Alright, so that would be the x component of the blue. The y component then would be using sine. So if you used cosine for one of them, sine will be the other one. And remember, sine is opposite over hypotenuse. And so this helps to kind of memorize them a little bit if you're just learning them. Alright, and so I'm going to put in sine of 65 equals the opposite side, which is my y, over the hypotenuse, which again is 80. So multiplying both sides by 80, and we're going to come into that same situation I was just mentioning, that it's always going to end up being hypotenuse times sine or cosine. So I would set it up y equals 80 sine of 65, and the y comes out equal to, so we'll do 80 sine of 65. I'm going to store that as my letter B. The first one I stored as letter A. And it comes out to 72.5. Alright, so we have both the x and y components of the blue. Now let's go ahead and do the x and y components of the green. And these are all going to be on the next slides too, kind of typed out so you'll be able to see it a little bit better in case you can't read my handwriting. Okay, so this one for the green, I can see I'm down here. Here's my 20-degree angle. And so what I'm going to be doing is I'm going to determine, is this going to be sine or cosine for the x? Well, this is the which side? Yep, good. It's the adjacent side. And so therefore, I'm going to use cosine for the x. So over here, I'm going to say cosine of theta is adjacent over hypotenuse. And I'm going to do cosine of, this time the angle is 20 degrees, equals the adjacent, which is my x, and the hypotenuse, which is, in this case, 100. So multiplying both sides by 100, it's going to cancel out my 100 on that side, and once again I'm left with x equals a hypotenuse times sine or cosine. So if at this point you're recognizing that and you'd like to bypass all the math up above, I'm okay with that as long as you understand what you're doing. So instead of writing the cosine here and then writing all this stuff, you could just write x equals the hypotenuse times cosine. Just be really careful with signs. And that's where, like on these triangles, I labeled the positive and negative signs. That'll kind of correlate up over into those. So this one is going to be 100 cosine of 20. I'm going to store that as my letter C, and it comes out to 93. We'll just put 0.97 because it's a 969. So therefore, we at least, I could have made it 94, but we'll leave it at that. All right, because I have the exact stored value. All right, that means the y is going to be sine, so I'm going to say sine of theta equals the opposite over hypotenuse. And so I would write sine of 20 equals the opposite side, which is going to be my negative y. And you can leave the negative sign out for now if you wanted to and just put it in later. I'm just going to throw it in just so I have it, and the hypotenuse being 100. So multiplying both sides by 100 again, I'm going to end up with y equals, and putting the negative sign on the other side, I'm going to have 100 sine of 20. Okay, so that's what I would plug in my calculator. I'd have negative 100 sine of 20, and I'm going to store that as D. So far I have A, B, C, and D. Okay, and so this came out to negative 34.2. And so now I just got one more to do, the red. Okay, and this is probably the easiest one out of all three, or should be. So if I'm looking at my x and my y components, I actually won't have to do any math, I just have to visually look at it. So in the x direction, is vector c going anywhere? And the answer is yes, it is traveling in the negative x direction, 60 of whatever it is. In the y direction, that means how much is it going up or how much is it going down? Well, this is just to the left. There is no y component, so I'm going to put in 0 for my y. And so we'd have all those x and y components. Not too bad. So this is using some of the math that we did yesterday in looking at the trig, and basically just solving triangles is ultimately what you're doing. So just getting practice with using sine and cosine. You'll notice when you're finding components, you're always going to use sine for one and cosine for the other. Technically, I was doing that here as well. The angle in this case would have been 180 degrees measuring from the x-axis. So I could consider this to be 60 times the, in this case it'd be like the cosine of 180, which is giving me the negative 60, because cosine of 180 is negative 1. And then I could also look at this being the sine of 180, which gives me 0. Alrighty. So now what's happening, let me go ahead and get on select, is we have some additional steps. And so these are some of the steps that we're going to be covering. So step 2a and then step 2b, technically it's really just step 2 where we are combining our vectors. So we're adding all the vectors for x, adding all the vectors for y, and that's going to give me an xy value for my resultant. You'll notice for this example, I actually drew all of my triangles separate, so I did not add them tip to tail. If I did, then I would be taking this guy and I would be dragging it right here, and then I'd be taking this guy and I'd be dragging it right there. Okay, so that'd be adding them tip to tail, so I've got to put those back. Alright. Okay. So basically from the previous slide, let me go ahead and kick back for a second and then I'll come back. Ultimately what we're going to be doing is we are going to be, I'll change my color, we'll make it purple, that looks good. So we're going to be adding this x and this x and this x. Okay? And that's going to be our total x. And then we're going to add our total y as well. So I'll go ahead and use it dotted for this one. So then we're going to use this y and this y and this y. And we're going to combine the x's and then combine the y's, and that's going to give me a total x and a total y. And so that's what this is saying over here. Oh. Get my eraser. Okay. So basically what this is saying is we're going to add all the vectors in the x coordinate, add all the vectors in the y coordinate, and that gives me my total x and total y. So basically I'm going to combine this, and I'm going to combine this, and I'm going to combine this. And notice that I'm adding them tip to tail. And so by doing so, here's where my total x would be, my total x resultant. So I could kind of fill that in with a purple pen. Let's do that. So ultimately this would be my total x component from start to finish. Cool, huh? And then for my y's, I would have this one, and then I would have this one. Notice I'm adding them tip to tail again, so I'm going to put the tip of the one to the tail of the other. And so my resultant for this one, start to finish, would be right there. Not too bad. And so therefore we have our total x and total y. Alright, so let's go ahead and take a look at step 3. Step 3 is that we're going to draw a new triangle with the x resultant and the y resultant, and we are going to add them tip to tail like I mentioned the day before when when I had you guys write down all those steps. Okay? So what I'm going to do is I'm going to take my x component of my resultant, and I'm going to take my y component of my resultant, and I'm going to add them tip to tail, and that is going to give me an overall hypotenuse resultant right there. Okay? And let's see if I can readjust that a little bit so that it's a little bit better. It's finicky. Okay. So basically it's about right there. So that would be my overall resultant, and you can see then that I'd have a 90-degree angle right in there. And so that brings us to our step 4 and step 5, and last thing, once we have this right triangle, we're just solving it. And so ultimately if I added these up, these vectors here, then I would know what this is and I would know what this is, so therefore I would know what the side here is and the side here is. So that's where I could technically go back to the values I found on the previous slide. So I'm going to take 33.8 plus 93.97 minus 60. Okay, so let's see if I can, we'll throw these back in. Alright, so we would take 33.8, which would be in mine, I stored it as A, plus my C, which was the 93.97, and then I'm going to subtract 60, because don't forget about the ones that you didn't actually do sine and cosine for. And that gives me a value of, so I'll go ahead and label my triangle here, and this is going to happen later as well, 67.8, thereabouts. Okay, and what you can do is you can then store that as your X on your calculator, and that way it's stored in as like big X, and that way you are able to reuse it later. Alright, then I'm going to add up B and D, and technically I'm adding in 0 because there was no y component for the third vector, letter C. And so that gives me a value of about 38.3. And I'm going to store that as my y. That way it's always in as my y if I needed to use it, which is what I'm going to do for Pythagorean theorem. So ultimately for Pythagorean theorem we're going to be solving for C here, which is going to be the hypotenuse ultimately. So I'm going to do 67.8 squared plus 38.3 squared, and then I will take the square root of that. And I'll do that on the next slide. And then lastly, we're going to use that inverse trig function, if you remember, to find our angle theta. So theta, since I started here, then I'm going to say that this is theta. Theta is always going to be from where you started, so kind of get that ingrained in your skull, that theta is always going to be from where you started. So don't make theta up here, because if this was like a treasure hunt or something, it's a lot harder to start at the end and know the angle to get back to the beginning. Okay, so make sure the angle is always from where you start. Alright, so if you need a pause at this point to write in the rest of these steps, go ahead and get this paused. Otherwise, I'm going to go ahead and move on. Okay. Maybe I'll move on. Alrighty. So like I said, I'm going to go through all the math here. This will be the itemized version of it, so we'll be able to see everything and know exactly how to do the math. It'll be a little more organized than what I did. Okay. So as I'm looking at these vectors, notice that I can kind of find the components just like we did before. So it'd be 80 cosine of 65. Where's the other one? Is it over here? Yeah. And 80 sine of 65 would be those vectors. You could see that I could drag this over and make my triangle. With the green one then, I can click here to get my total x, and click, over here to get my total y. So you can see that I'm going to have all my x's and y's. Then I have this one, which is ultimately going to be my x component, so I can add on the negative 60 and I can add on 0. And in doing so, 80 cosine of 65, 100 cosine of 20, there's your 33.8, there's the 94, and it gives me that 67.8 I had on the previous slide. And then if I did these ones, I'd have 72.5 minus 34.2, and that gives me my 38.3 that I had. Alright, so to do the math then, we're ultimately going to combine all of our vectors. So we're going to get a pink vector. I believe, where did I put them? I think they're over here. Yeah. And I should have one more somewhere. There we go. Okay. So ultimately what's happening here, if I wanted to add these tip to tail like I was mentioning before, I can't move those ones. Okay. If I want to add these tip to tail, ultimately it doesn't matter where you add them from. So if I was to say add that vector there and add this vector here, then I could create my resultant by going from, once again, where I started to where I ended, and check that out. So ultimately, my resultant vectors, these purple lines here represent the 67.8 and the 38.3. So 67.8 here, 38.3, and then my resultant vector, oh my goodness, look what just happened, is going to go from start to finish. So green to blue to red, and then the resultant from start to finish. So that is pretty sweet. I don't know about you guys, but I think that's pretty awesome. And the even more awesome thing is, not highlighting that, the even more awesome thing is I can actually go in any order I want. So this is like commutative property of addition. So I could add vector A, these are actually slightly off, but I could add vector A and then add vector B and then add vector C, or I could add vector C, then go to A, then go to B, or B, then A, then C, or B, then C, then A, or A, then C, then B. It doesn't matter what order. So ultimately, here's kind of then your math. If I was doing Pythagorean theorem, so I would take this x value, being the 67.8, and the y value, being that 38.3, take the square root of the squares. This is Pythagorean theorem just already solved for C. So this is like C equals a squared, square root of a squared plus b squared. And then to find the angle, I was mentioning, and here's the tangent. So I would take tangent theta equals the opposite over the adjacent. And in this case, the angle that I'd be using, let me go ahead and fill it in with the purple pen. The angle I'd be using would be down in here, and that's because this is from where I started, so I started down here. So then if that's my angle, my opposite side is going to be my 38.3. My adjacent side is going to be my 67.8. Remember from here, in case I need to get rid of tangent, just like if I was doing an additive inverse or multiplicative inverse, I need to take an inverse tangent of both sides. In doing so, inverse tangent of tangent is going to cancel them out, leaving me just with theta. But then on this side, I would have the inverse tangent of this quantity right here, and that's what I see right there. Remember that you need to be in degree mode, otherwise this number will come out strange. It'll be small, might be negative because it'd be in radians. And so my angle comes out to 29.5 degrees. So my final answer for this, if I wrote out the whole thing, I would write 77.9 at 29.5 degrees. And the cardinal direction here, I first went east and then I went north of east. And I would write that in. So anytime that you are doing these example problems in this chapter, this is what it's going to look like whenever you get your final answer. If I am asking for a vector, I need both the magnitude and the direction. And the direction is not just the cardinal direction, it's also the angle. All right, so that's the very first example under our belts. If you got a belt on today. Okay. Is this just a repeated slide? Let's see. Let's get rid of this first. Okay. Okay, that was just going through the totals separate. So, yeah, same exact thing. So we just did that. All right, cool. I didn't want to go through that again. All right. So let's see if we can do this one. So as I'm looking at this particular example, let me see if I do. Yeah, okay, good. If I do this particular example, we're going to do all the steps on this one slide here. So first of all, remember that we have to go through step 1, which is to break each of these into x and y components. And so it's kind of hard to see because the 30, let me shrink it down a little bit. That's better. Well, that's really tiny. Okay, so the 30 degrees is actually found in there. I'm going to go ahead and switch over to blue. And remember, we got to find the x and y components of these. So if I was to create a triangle here, your coordinate axes, whatever angle is made with respect to, in this case it's the y-axis, then I'm going to use that as one of my components for this triangle. And you can once again draw these separate. You don't actually have to have your xy chart on here. You can just have triangles randomly written or drawn on your paper. Alright, so in this example, would you say that this is the x or the y? Yep, exactly. It's the y component. So I'm going to go ahead and label that as y. And would it be positive or negative? Careful. Remember, you're starting here and you're ending here. So you're going to trace going this way first and then this way. So we're going to be going up. That's a positive y. And then this is my x component. Would you say going this way is positive or negative? Nice. Yep, exactly. It's a negative. And so therefore I'm going to go ahead and solve these using sine and cosine. Remember the hypotenuse, whatever the vector is given as, that's always going to be written on the hypotenuse. I'm going to use the shortcut or shorthand method for this one. So I'm going to say that the x component for the blue is going to be the hypotenuse, which remember x component is negative. Hypotenuse, which is 45, times, in this case, would I use sine or cosine for the x? Yeah, exactly. This is different than the ones from the last example in the sense that this angle is made with respect to the y-axis. So actually this is using sine instead of cosine. So the x will not always be cosine. And my angle is 30 degrees. Okay. And so then I could type these in, negative 45 sine of 30, which I know is going to be negative 22.5 because I know my unit circle. Okay, and I'm going to store that as a. So this is actually just overwrote, or yeah, I guess overwrote the quantity that we actually had in for a from the previous example. So it just does it automatically. All right, so that, like I said, this gives me a negative 22.5. All right, then the y component is going to be the hypotenuse of 45 times, in this case then. If I already use sine, I can just kind of not even think about it and just say this is going to be cosine, but let's double check. So this, compared to my angle, is the adjacent side, which means that it definitely is cosine. And so I'm going to do 45 cosine of 30, and that's going to give me 38.97. Let's just call it 39. And we have our x and y components of the blue. Okay, let's move on to letter B, which is the green. This one is completely straight down, so since I don't have a triangle for it, I'm just going to do my x and y components since it's completely vertical. X component, how much is the green vector going left or right? You got it. It's not, so therefore we'd put a 0 in for the x. How about the y component? How much is it going up or down? Nice. So it's going 75, but remember, there it is. It's a negative y. And the reason it's a negative y is because it's pointing downward. And you guys are like, well, yeah, I know, Mr. Schmidt, we get it. Okay. So let's take a look at the red. And so the red, once again, is only going to be an x and a y component that we don't have to do math for again. And I can see that in the x direction, where's this going? Yep. Negative 60. I hope you guys are actually like responding, otherwise this is kind of weird. But we'll see. Maybe you'll start responding for the rest of these. Okay. And the y component is 0 because it's not going anywhere up or down. All right. Well, that makes this one not too bad. So now what we're going to do is we are going to combine our total x's and total y's. So I'm going to go ahead and do that over here. So my total x is going to be a negative 22.5 from the blue plus 0 from the green plus a negative 60, I'll go ahead and put in parentheses, negative 60 from the red. So that's going to be my total x. And my total y is going to be 39 from the blue plus a negative 75 from the green and plus 0 from the red. And so I can combine these, so I'm just going to hit alpha A, because I remember I stored that negative 22.5 as my A, and I'm just going to subtract 60 from it. And they're both negative, so that gives me a negative 82.5. And you guys could have calculated that because this was an actual number and this is just 60, which is an actual number as well. Okay, or I should say whole number, rounded, terminating decimal, all that fun stuff. All right, then we can do the y. Before I do that, I'm going to store that as my x value, so I don't have to do anything else in my calculator, and I'll explain what I'm going to type in my calculator then for this one. And so now I'm going to put in b, and then minus 75, and I'm going to store that as my y value. And so that gives me a negative 36 point, technically 02, so we'll just make it 36.0. Okay. And so I have my total x and my total y. Now we're into step number, let's see, that would be step number 3. What we're going to do is we're going to draw a new triangle. And so once again, you can start with the x or start with the y. This is a negative x and then a negative y. So my triangle is going to go like this, negative x, and then from the end of it, negative y. And so my resultant is going to be right there, and it's traveling from start to finish. Okay, which means, is my angle going to be here, or is my angle going to be here? Remember, if we're going on a treasure hunt, where do you want your angle to be? Always at the beginning. So we're going to make my angle right here. So that's going to be my theta. And this would technically be my 82.5. And this is going to be my negative 36. So I'm looking for my resultant. So I'm going to use Pythagorean theorem. And so remember, my resultant, if you want to do the shorthand version, then it's going to be the square root of x squared plus y squared. And you could do this on your calculator if you stored those values in as your x and y. So I'm just going to hit the square root button, parenthesis, x squared. So I'm going to bring in that alpha x. And then I'm going to hit a plus, and I'm going to do alpha y squared. And then I'm going to close my parenthesis. So it's going to look exactly what I got there, aside from the fact that on this slide, or on this screen, I actually didn't put my parentheses in here, but I would have those parentheses. And I hit enter, and it does the math for me. So it comes out to 90.02, so I'm just going to call it 90.0, no units again. And so now, we're not done yet. That's just the magnitude. Now we need the direction. Remember the direction, I'm going to use this value of negative 36, and I'm going to use this value of negative 82.5 because this is my opposite side, my adjacent side. If I use the resultant, I mean, I could, because I mean, I have the resultant and it's an actual value, but a lot of times I like you guys to use this or this, simply because those are more or less not rounded as much. So you should be able to get a better or more accurate answer at the end, unless you stored it all the way through like I do. Alright, so because I'm using opposite and adjacent sides, I am going to be using tangent. So I'm going to write in my tangent. So tangent of, in this case, theta, because I don't know what it is, equals, I'm going to leave a space, and it's going to be a negative 36 over negative 82.5. If you want for these, you can actually just leave out the negative sign, because the picture will give me my cardinal direction, so I'm not really worried about the positive or negative signs in here. Yeah, in this case they cancel out, but they're not always going to cancel out. And so if you leave the negative signs in there, it's just going to give you a negative value, and it'll be back to the unit circle example, like the help and everything I did yesterday, where I said all of the vectors are, all the trig functions are positive in quadrant 1, sine is positive in quadrant 2, tangent's positive in quadrant 3, and cosine is positive in quadrant 4. So like if I'm doing tangent here, if I got a negative, that just tells me it's going to be either in quadrant 2 or quadrant 4. But if I get a positive value, that tells me it's either in quadrant 1 or quadrant 3. And check this out. What quadrant is this going to be in? It's going to start out going back and then down. It's going to be in quadrant 3. Should be positive, and look at that. There is a positive sign in there. So just leave out the negatives when you're doing tangent if you'd like. Also, I would recommend leaving out the negatives here, because you're going to be squaring the negatives anyways, and it's not going to matter. But if you leave out the parentheses, then it's going to mess up your problem. So for these last two steps, if you want, just make your total x positive, total y positive, and that way you'll get this accurate for sure. And same thing over here. So what I'm going to do is I'm actually going to take an inverse tangent of both sides. And remember, I do this because I need to get rid of that tangent. Okay? So what's going to happen is the inverse tangent and the tangent are going to cancel on that side, and I'm going to be left with theta. Theta is not going to change. So I'm going to say theta equals, in this case, inverse tangent of 36 over 82.5. So I'm going to do in my calculator, I'm going to type inverse tangent. If it's a TI-86, it doesn't actually put the parenthesis in right away, so you got to make sure you put a parenthesis. If it's a TI-84, it'll actually put the parenthesis in for you automatically. And then I'm just going to, because I have my function stored, I'm going to put in inverse tangent of y divided by x. So I'm going to hit alpha y divided by alpha x because I have those stored in. I don't have to actually type in those numbers of 36 and 82.5. I hit enter and my angle comes out to 23.6 degrees. And the last part, cardinal direction. So I'm first going west and then I'm going south. So I'm going south of west. Okay, so that is the second half to my answer, and that once again was the first half to the answer, and you could have 90 at 23.6 degrees south of west. So these aren't too bad, right? It's like a nice even steps to go through. So find components, add up components, redraw your new triangle with your totals, Pythagorean theorem, inverse tangent. So it's the same thing each time, unless you want to do it a different way. Okay, so this time let's try another method. And this some of you probably have seen before, some of you may not. If you want to, just kind of ignore everything I'm going to be doing right here if it starts to confuse you. Okay, so I'm going to go ahead and group these together. And I'm going to group these together, I'm guessing. Yep, good. I redrew that later. Okay. So here's what's going to happen with these. You can only do this method, first of all, if you only have two vectors. You could technically do it with more, but you're just going to have to do it multiple times. So what's going to happen is, with this method, we're actually going to draw these tip to tail instead of drawing them separate. Okay? And so that's kind of what I'm going to be looking at here, is I'm going to be drawing these completely combined together. All right. What we're going to be using here is, for those of you who have heard of it before, we're going to be using the law of sines and law of cosines. And some of you are like, oh, I hated that, if you took trig and everything already. But it's really not as bad as it sounds. And this one, as long as you're able to kind of go through and figure out what's going on with these problems, then you're in good shape. So in these problems, I'll give you the vectors and I will actually give you the angles. So I didn't write the angles in here. Let me go ahead and write in some angles. So this looks like, let's call it, let's just call it 30 degrees. We'll make it easy for you guys. And for this one, we'll make it we'll make it 60 degrees. So let me go ahead and put in a 60 degrees here. Okay. So that means that as I am adding these, I guess it's not totally, if that's, yeah, okay. Well, we're close enough. All right, so what I'm going to do is I am first of all going to draw in my resultant. And remember that when you draw in your resultant, it is from start to finish, so hopefully this will be fairly straight. That was pretty snazzy. Okay, so you'll notice that my resultant vector, when I draw it, that's going to make this not a right triangle, and that's the key. So if it's not a right triangle, I cannot use sine, cosine, and tangent. But I can use the law of sines and law of cosines. So you're probably asking me, well, Mr. Schmidt, what's the law of sines and law of cosines? And I would answer, well, law of sines is this. It's basically the sine of A over A equals the sine of B over B equals the sine of, you guessed it, C over C. Okay, so you just are basically labeling this as what you think you want to use. So I'm going to call this, we'll call this one C. So let's call this guy C. Let's call this guy A, why not, and this guy B. And it really doesn't matter, as long as you're consistent. So you notice that I labeled the angles as the capital letters, which means that the sides, so this purple side is going to be little a, this red side is going to be, see how it's across from the angle B, so I'm going to call this one little b, and across from angle C, which would be not the 30, but actually just this little guy inside here, and so this is going to be little c. Alright, and so the law of cosines, on the other hand, since I'm probably going to be solving for, since this is my starting point, I'm going to be solving for c, so I'm going to put c squared equals a squared plus b squared minus 2ab cosine of capital C. So you notice that this is the side, so if I kind of like broke it and stopped and ignored this last portion, this kind of looks like Pythagorean theorem right here. Okay, and then I have this extra little piece added on, so I have 2ab, which is these same two here, and cosine of c. And I can't remember if I put it on your equation sheet or not, but if it isn't, I'm pretty sure I did put it on there, but if it isn't, then you can easily add these two on there on the front middle of your equation sheet. Alright, so let's get started with this one. So we first of all are going to have to use a little bit of geometry. So what I'm going to do is I'm going to go ahead and get my red pen, and I'm going to kind of think, okay, this triangle here would be completed as a right triangle if I did something like that, and you guys can probably visually see that one now. And so that means that this angle in here is going to be a particular value, because if this is 30 and this is 90, that's going to make this how much? Right, exactly. So this is going to be 60 in here. And that's huge because we need to know this inside angle. And you should be able to find it every single time in some way using either alternating interior angles, or it might be just creating a triangle like this one. All right, so let's give this a whirl. So what we're going to do first is we're going to use the law of cosines, because what we need to do is we're going to be looking for this angle right in here. Okay, to find that angle in there, I need to know, so I know the opposite side from it, but I need to know another opposite side from one of the angles. This is an unknown angle, this is a known angle, but I don't know the side in order to use the law of sines. So when you're doing these, you're ultimately going to basically know this inside angle, and you're going to have to find this opposite side. Okay? So what you're going to do is we're going to use the law of cosines. So I'm just going to plug in from here. My c squared is going to be 6 squared equals my a squared is an unknown plus my b squared, which is 10, minus 2. Actually, do I want to do this one? Because I have two unknowns here. Okay, so instead what we're going to do is we are going to, sorry, I started with the wrong one. We're actually going to use the law of sines first. Okay, let me go ahead and erase. That's what happens when you take a summer off. Okay, so let me see if I can, if this works with this one. Oh, nice, it does. All right, good. So let's try this again. So ultimately with law of sines, notice that it's based on one angle that's known across from a side that's unknown, and so forth. Actually, we can't do this one either. Okay. So instead, let's see. What did I do? No? Okay. All right, so let's go back to the law of cosines. And so let's go ahead and fill that in. And so law of cosines, what we're going to write is we are going to put in little c, which is going to be a known. We have b, and we don't know a, and we don't know a side. Okay, and we know the opposite angle. So we're going to do this for, okay, I see what I was doing. All right, I was doing it backwards. So we're actually not going to solve for c, we're going to do a different version. Okay. So what we want to find is we ultimately want to find side A. And so finding side A, we know angle A. So you have to have an angle that you're going to use in here. So I'm going to set this up as a squared equals, so notice I'm just rearranging the other variables, b squared plus c squared minus 2, notice now I'm going to use bc as opposed to ab, cosine of a. So there are three different versions of law of cosines, and it's all based on looking at the A, B, and C arrangement. All right, so this time, this should work much better. All right, so we're doing this side equals b squared, which is going to be 10 squared, plus c squared, which is going to be 6 squared, minus 2 times 10 times 6, cosine of our known angle, which is 120, because it's 60 plus 60, the whole 120 for angle A. All right, now you can see we only have one variable. We're good to go. So brain lapse there, my bad. All right, so now we're just going to multiply this. So 10 squared is 100 plus 36 minus, let's see, 60 times 2, so 120 times cosine of 120. That's not always going to be exactly the same. So 120 cosine of 120 gives me negative 60. So it's minus a negative 60. Okay. And then I have a squared equals then 100 plus 60. 160 plus 36 is 196. And a is going to be the square root of that. And everybody should know and memorize each and every single one of your perfect squares. And this is a perfect square, comes out to 14. All right, so 14 meters. We're actually given units for this one. Okay, so now that we have A, check it out. We know A and A. That's great. So if you know one of these like completely that you can fill in for it, then you can find the other. And we're trying to look for C, so we're actually going to just ignore B for this, and we're going to focus on C here. I do know side C, so my unknown is going to be capital C. So I'm going to write sine of A over A equals sine of C over C. And remember that, like, anytime you have an equal sign between multiple parts, you can just use the two parts that you actually need for that equality, because all parts are all equal. So if I plug in my numbers, sine of A is 120 over side A, which we just found to be 14, equals sine of C, which is our unknown angle, over side C, which is 6. And so this is a proportion. We're just going to cross multiply, so 6 times the sine of 120, and that's going to give me 5.196, and I'll keep the exact when I do this, equals 14 times sine of C. So first I'm going to, because this is multiplied, divide both sides by 14. So I'm going to get 0.37 equals sine of C. Okay, so this is the same problem we have when we're actually trying to find our angle in these resultants. So I'm going to use an inverse trig function. What I would actually use is going to be inverse sine. So I'll go ahead and kind of fill this in. So it's going to be basically like an inverse sine of this side. And I'm ultimately going to be doing an inverse sine of that side. And so what happens then is my inverse sine and my sine cancel over here, and I'm going to be left with C equals the inverse sine of our previous answer, which should come out to about 21.8 degrees. So this letter C is this angle right in here that I mentioned before, okay? Which means then that if I wanted to find what the overall angle is, since I found my resultant, there's my resultant, the purple line here, but I need to know how much it is, say, right here. So if I know that this total is 30 and I know that this is 21.8, can you guys find what this would be? Absolutely. So what I would do is I would just take 30 minus 21.8. So I'm going to take 30 minus that answer I just found, which comes out to 8.2 degrees, and I'd be going over east and then going over north, so this is north of east. And that would be my final answer. So sorry about the hiccup earlier, but when you're doing these examples, you want to make sure that you only have one unknown. You're always going to be looking for your hypotenuse first. I forgot that. And so as you're going through these, basically you're going to add your vectors tip to tail. Once you have them tip to tail, then you need to be able to find what this inside angle would be. So depending on how these are drawn, if this one was actually drawn kind of cutting in here, you'd have to be able to find what that is, maybe by knowing what this is and subtracting off of the total angle you'd find. But it's just using a little bit of geometry. Okay. Once you have that, then you can plug all that stuff into your law of cosines based off of this angle that is on the inside. And then once you find what your resultant is, then you can use your law of sines comparison and go from there. If you really wanted to, you could actually then go do a law of cosines again for letter C if you really wanted to and you don't like the law of sines. Alright, so that is using law of sines and law of cosines. And if you need me to go through another one of these after I get back, by all means I will definitely do that. Alright, so that is going to be it for this discussion. If you have questions, just ask me. You're going to be going through, coming up, you're going to have a lab, and you're also going to have some example practice problems, so I think in reverse order there. So we'll go through the examples, and hopefully you guys can do a little bit better with those and progress in adding up vectors in 2D.